As it keeps running, it runs into the metering device. Now, it depends on the type of metering device. This could be a fixed metering device, capillary tubes, a thermal expansion valve. Most units nowadays have a thermal expansion valve. If it doesn't have that, then it has a fixed metering device, which is a little piston. This device sprays a small amount of refrigerant through the thermal expansion valve into, in this point would be called the distribution tube, which is the start of the evap coil. The evaporative coil, once that liquid hits its coil, it gets bigger right away. As it goes from a 3/8 line, now you're talking about a 7/8 inch pipe. So the sooner as that liquid gets sprayed into that pipe, 20% of it flashes and boils off. Our 410A boils off around 40 degrees. So as long as that coil is over 40 degrees, it's going to boil off some of that refrigerant into what's called a flash gas. So it's no longer liquid, it's 20% flash gas, 80% liquid. And as the refrigerant runs through this, constantly running through this pipe, it's changing from a liquid back to a vapor. And how it does that is by using the heat that's in your room air that's being blown by a fan from inside your house, from the return duct where the filter's at, through the supply air, which blows the cool air out in your home. It's taking that heat off the air that already exists in your home, from you breathing, from the sun, from cooking, from TV, from lights, whatever it is. That heat that's already in the molecules of your air, it's taking that heat, boiling the refrigerant at 40 degrees, and absorbing that heat. So a lot of people think that the air conditioner blows out cold air. It really doesn't. The air conditioner's job is to remove the warm air molecules from your air that's already in your home, leaving it absence of warmth. We live in a world right now that we have a sun. If tomorrow the sun went out, we'd be ice cold, because the sun is what heats us. Just like lights heat us, flame heats us, energy heats us by rubbing our hands together real quick. You'll feel that heat building up in your hand. That's all forms of energy. So to have this work, this system has to remove the heat from the air already in your home, leaving the air absence of heat or absence of measurable heat when it comes out. So in the cycle, as it runs through this evaporative coil, it's changing from a liquid to a vapor again. And it does that by absorbing the heat that's in your home. As it comes out, it runs up the coil to the suction line, which is the line that joins the indoor coil or the evaporative coil and the compressor. It comes back and it starts this cycle all over again. It's constantly doing the exact same thing. Every time your thermostat turns on a switch, it starts up your compressor, it starts up the fans, the system works again. A constant cycle. If you don't shut it off, you turn your thermostat really low, this system will constantly work all the time. It will never stop. One little bit of refrigerant, an ounce of refrigerant replaces the next ounce, replaces the next ounce, and it's just constantly pushing through the system. So again, the cycle is a constant cycle. Most people think it starts with a compressor, but it really doesn't, because it starts back here. When the compressor turns on, there's already refrigerant in this line that's being sucked towards the compressor. But the compressor is the energy source that makes this work this way.